Hello, my name is Gabriel from the NIP Embedded team. Today I'm going to show you how to repair a battery using the NLBA1 device. Let's get started. We have here a nice Lenovo battery that doesn't work anymore. Let's connect it to the analyzer and see if we can repair it. We already have the connection made on the connector, so we just connect the battery into the connector like this, and then we analyze it on the software. In order to troubleshoot the battery, we need to read the dynamic and static battery data. We see here that the chip is locked because the cells are over-discharged and unbalanced. We also see that the cycle count is 69, so it's a low cycle count. Full charge capacity seems good because the design capacity is near the full charge capacity, and the manufacturer data seems also good. So we can repair this battery by pre-charging the cells. We need to check one more thing in the reset tab if the chip is supported. And yes, the chip is supported. We can now open the battery and pre-charge the cells. Now we are going to disconnect the battery from the analyzer and use a knife in order to expose the PCB where we can charge the cells. Let's get started. We are going to cut this like this and cut this also. The PCB is right here. But very carefully, because here are the cells and you don't want to knife to cut the cells because they can explode very easily. So very carefully. I think I found the PCB. Yes. This battery is very easy to open. I think I need to cut through this. Like this. Yes. Yeah, looks like I open up the battery, and here are the cells. Let's start and pre-charge the cells now. I'm gonna start with lower voltage and low current, and I will increase till I get to like 3.3 volts, something like that. First, I will check with the multimeter for the plus and minus. Let's see if the multimeter is. So this is the minus, this is the plus. And here, this is the minus. So keep in mind, this and this minus. Let's start charging the cells now. Let's raise the voltage now. I think that's enough. Let's connect now the battery again to the analyzer and see what we have on the software. While reading the battery data, we see that the chip is locked and the cell voltages are good now. So that means we have an error on the chip. Let's go to this reset tab and see what error we have. The chip is supported. So we read chip info. We see that on the PF status we have a cell under voltage failure. First thing we need to do is to save the EEPROM. In order to save the EEPROM, we need to unseal first. We read chip info to see if the chip has been unlocked, and yes, the chip is in fast mode. We read now the EEPROM. And we are syncing to a file. Done. Now, read the chip info again. We are in fast mode, so we can clear chip errors. We clear chip the errors. We read chip info again. Look, now the PF status has been cleared, and now the battery should work. Let's see. The chip is now unlocked. Let's see if the battery charges. Yes, we have current. And the battery charges. We can test the battery if the battery discharged because the state of charge is 0% and I can't discharge from 0%. But I can charge the battery and then I can discharge the battery successfully. And that's how it's done. With the help of the NLBA1, I was able to repair this battery quickly and easily. If you enjoyed this tutorial, please give it a like, subscribe and hit the bell so you don't miss future videos. Leave a comment below if you have any questions or suggestions. See you next time. Bye!